So I'm going to try and go through this applet the same way that I went through the workshop, which is by starting by saying that I'm not going to go through every single tool on the toolbar up here, because it's quite nice to play around with these things to yourself, and you really don't need me to go through them. You can see it all for yourself. So I'm not going to go through all of that, but I am going to talk about the applet that's on the presentation, which is approximating pi. And the first time I saw this applet was on Guillermo Bautista's blog. It's called Math and Multimedia, and it's an absolutely brilliant blog. Definitely recommend that you have a look on it. And on that blog there are 30 Geogebra tutorials that really helped me when I was starting to get into Geogebra and become more of an intermediate user with Geogebra. So I'm actually going to go through Guillermo Bautista's applet. I'm not sure if I'm going to go through it in the same way that he does it, because it was quite a few years ago that I looked at those, but I just remember that he did an applet similar to this. So I'm going to go through it now, and then what I'm going to do is I'm going to try and add to that and do it in a different way, maybe in a separate video, and show you how applets can be made in a different way, possibly slightly more efficient than the first way that I do it. But just to start with, so if I'm going to approximate pi using Archimedes' method, I'm going to need a circle. So there are a number of ways I can put a circle in. I can start by going to the input bar and doing the standard equation for any circle: x squared plus y squared equals the radius squared. So let's say I want a circle with radius 3, put 9 in and I get a circle with radius 3. In the algebra view, you see the equation of the circle right there. And if you didn't have your algebra view open, then I'm just going to close this and show you where you can go to find the algebra view. So I'll close that, go to view, go to algebra view, and the equation's right there for you. I often have the algebra view open when I'm doing applets. It just kind of gives you a sense of the things that you've done, and helps to remind you what all of the things are called. So for example, this circle's called conic C, so that's going to come in useful. So I'm just going to click this and press delete on the keyboard. I'm just going to get rid of that, because there's another way that I can make a circle, and I can do it using a Geogebra command. If I simply start typing in circle, then there are a number of commands that come down, and you might not be able to see it on the video, but the first one is I'm going to press enter on that one, and I've got my command there. And the point, it wouldn't be a wild guess to assume that the point for the circle will be the centre point, so I'm going to put in 0.00, and the radius again being 3. Press enter and you get exactly the same thing that you got when you entered the equation in. Now there is another way that we can make a circle, so I'm going to delete that again, and I'm going to go to the tool function, which is probably the way that I would have done it when I first started using Geogebra. So if I click on the tool, or if I hover over the tool, then it tells me what I need to do. So I need to select a centre point, then a point on the circle. So I'm going to select this, select a centre point and a point on the circle there. There we go. Now on the applet, on the approximating pi, what we need to do is we need to inscribe some polygons inside that circle. And we need, so what we're going to need to do is we need to make a slider to get those polygons going, to have different polygons with different numbers of sides. So I'm going to click this slider, click anywhere on the screen, or on the Geogebra interface, and then I'm going to get my slider bar. Now the name of this slider, I'm going to call it n for the number of sides of the polygon, which means that the minimum value for n would be 3 for an equilateral triangle, and the maximum value, let's just say that that's 50, a 50-sided polygon for now. And because the number of sides is going up by 1 every time, three-sided polygon to 4-sided to 5-sided, it only makes sense to have the increment being 1. So if I apply that, then I have my slider. I'm just going to go into the move function, and you'll see there that I can move this slider. Now nothing's going to change because I've not actually I've not made any equations yet. I've not defined anything that are based on n. I've got my variable, and I now need to start defining some things that are based on n, so that things start moving on the applet. Now, in this particular case, what we're going to try and do is we're going to try and make a second point of each polygon. So if I think first of all about the simplest case for an equilateral triangle, where's my second point going to be? Well, it's going to be somewhere around here. And my third point is going to be somewhere around here. So I'm going to have an equilateral triangle around about here. So thinking about that, if I think about the x-axis being my being the line that I take my angle from, if I go from there and I go, so about 120 degree angle, I'm going to get my next vertex of the equilateral triangle. And in fact it is exactly 120 degrees, sorry, because it's the exterior angle of an equilateral triangle. So I somehow need an angle. I'm going to need to rotate this point 120 degrees for the equilateral triangle. But the problem is, when I increase the slider to 4 sides, so I have a square, my next vertex needs to be 90 degrees away from B. So it needs to be rotated 90 degrees. And the next one, for a pentagon, for 5-sided, needs to be rotated 72 degrees. So I need to think about what I'm going to do when I rotate this point B. And first of all, I'm going to have to go to the transformations button up here, click on the bottom right, and I've got 6 options there. The fourth one is rotate object around point by angle. So I'll click that, and then all I need to do is click point B, click the center point, and I can now put in my angle of rotation. Now, as I said, for the triangle it needs to be 120 degrees, the square needs to be 90, pentagon 72, etc. And the way that I get those angles is the same way that I would get any exterior angle for a polygon, which is by doing, for a regular polygon, just doing 360 degrees divided by the number of sides. And the number of sides in this case is n. And it's okay that we've got this rotation being anti-clockwise, that's fine. So I click OK, and there we go. There's B. There's our second vertex of the triangle. If I increase this slider to n, it should go to it should be 90 degree rotation. There we go, and you can see that if I increase n, then I'm getting the second vertex of each polygon. So that's great. Now all I need to do is go to the polygon button. Just click on the bottom right again, and go to regular polygon. Click on that, and then I can click point B, point B dash, and it gives me the number of vertices that I can input. The number of vertices is of course going to be n in this case. So click OK, and there's the equilateral triangle that we were talking about at the start. And if I keep increasing n, then the number of sides of each polygon is going to increase accordingly. Now looking at this, it looks a bit messy with all of those points and labels on there. So I think what I want to do is I want to get rid of all those points, and I could do that in a number of ways. I could go to this button up here, the Move Graphics View button, click on the bottom right, and there's a function here that says Show Hide Object. So I could click on that and click on each point one by one, but that's going to take a while, so I'm not going to do it that way. I'm going to go onto this Move function, select the entire thing, so it's all selected there, right click within that selection, and go to Object Properties. Now, on the left hand side you'll notice that everything that I've selected has been selected in the toolbar in the Object Properties. Now all I want is to get rid of the points, so I'm just going to select the points, and by clicking on that top point button, I think I've just got all the points selected. Yes, I have. Brilliant. And now all I need to do is I just need to unshow all of those points. So unshow them, and all of that's gone white. And if I show you on the applet, then we've not got any points there, so that's looking a bit tidier now. That's looking much better. Now I need to find the circumference of my circle and the perimeter of the polygon, so I can start to approximate pi. Now there are a number of ways to do this. There are a number of ways to do pretty much anything on Geogebra. You can always do it in different ways. But to find the circumference of the circle, I could use a command. So I could start by typing in circumference, and while you can't see this, what comes up is a command circumference. I'm going to press enter, and I've got the circumference of the conic, and it's the conic C up here. So I'm just going to press C there, press enter, and I have my circumference of this circle being 18.85. I could have done that by putting in the equation into the toolbar, so I'll just call it surf as circumference, pi times, now the diameter of this circle 6, so pi times 6, and I'll get 18.85 again. So there's two different ways to find the circumference of a circle in Geogebra. Now to find the perimeter of the polygon, I'll use a function for this, so start typing in perimeter, pretty simple, and perimeter of polygon. Now this polygon's called poly1, so I'll just type that in there and press enter, and I've got the perimeter of this polygon of this triangle being 15.59. And that's going to change as I increase the number of sides. Indeed, that's going to get closer and closer to the circumference of the circle as that increases, which is going to start approximating pi better and better. Now, I could have these numbers simply in the algebra view, that's fine. But I think if I want to make a clear applet, I'm going to want them on the actual interface. So I'm going to go to the ABC tool, click on that, and then click anywhere on the screen. So click there, and then I can start inputting some text. So I'm going to put circumference of circle equals. Now I could just simply put 18.85 right in there. I'm not going to do that. I can click on the object, and it comes up straight away for me. Or I could go to objects and go to the object O, and there I've got the circumference of my circle as well. So press OK. That's looking a bit small, so I'm going to click on it and just increase the size of that to medium. There we go. Now I just want the perimeter of my polygon, so I'm going to do the same thing again, but with perimeter. Click anywhere. Perimeter of polygon equals, I think I'll just press U there and call that centimetres. There we go. Let's make this a bit bigger. There we have that. And as I increase n, you'll see that the perimeter is getting closer and closer to the circumference of the circle. Now simply for the approximation, so for pi. And all I need to do for pi is take u and divide it by the diameter of the circle, divide it by 6. Because this polygon is going to get closer and closer, is going to start approximating a circle as n increases. So pi is going to be approximated better and better when the perimeter is divided by 6. So if I say pi equals 6, u, the perimeter of the polygon, divided by 6. There we go. Enter that. And we've got an approximation to pi, for pi to start with as 2.6 for the inscribed equilateral triangle. You wouldn't expect the approximation to be very good for an inscribed equilateral triangle. So so that seems fine. I'm gonna put that on the screen as well. So I'm going to go to ABC again. Click there. And for pi, well, if I go to symbols, basic, then you'll see that you can click pi straight away there, and you can get a value for pi. Now that looks a bit kind of straight edged, so hopefully it'll look be a slightly nicer style in latex. So I'll change that to latex. Now I'm just going to get an approximately equal sign. So I think if I go to this button here, there's approximately equal to. Press that, brilliant, and then just press pi, and there we go. Let's make this a bit bigger, and there we have it. There's our applet. Now if I increase the number of sides, what you'll notice is that pi becomes a better and better approximation to pi as the number of sides increases. But the problem is, it only goes to 2 decimal places. So I'm going to have to go to options, rounding, and I think I'll round to 10 decimal places. And that's much better to approximate it. And I can increase the value of n if I wanted to. So there's one way in which you could make this applet, and well, not too bad at all, I think. I'm quite happy with that. So in the next video I'll show you a slightly different way, which is possibly a bit more efficient, works a bit better for large values of n when you start getting to say 10,000 sides of a polygon. So watch that video if you fancy finding out a bit more.